All right, so percentile notes. We want to find the z-score that represents the lower 25% of the data. So what is the z-score that represents the lower 25% of the data? So now I'm giving you the percentage, and we're kind of working backwards. A lot of times that's how math works. What's like one of the first things you learned in math? How to count, right? And then after you learn how to count, you might learn how to count backwards. And then maybe like kindergarten, first grade, you learn how to add. And then what'd you learn to do after you learned how to add? Subtract. And then maybe like second, third grade, you learn how to multiply. And then you learn how to divide. So now we've learned how to find the percentage. And now I'm going to give you the percentage, and we got to go kind of backwards. So kind of like how math growing up worked. Math in high school works a lot the same way. We learn how to do something, and then we learn how to do that backwards. So this time I'm giving you the percentage. So if we were to draw a bell curve very quickly, the middle z-score would be 0. We got -1, -2, -3 z-scores, 1, 2, and 3. So what z-score would give me 25% to the left, the lower 25%? So I don't know exactly where this is. I'm going to guess it's about right here, maybe. So what is the z-score right there? Somewhere between -1 and -2, likely. But what is that z-score? I don't know. How can we find it? We could go back to the chart that we did on Monday, and we could actually look for 25% on the inside of the chart, which would be 0.2500, or as close to that as we could find. But Desmos will also find this for us. So I'm going to go away from the chart. I'm not going to show you how to do it on the chart unless you just really, really want me to. I'm going to show you how to do this on Desmos today. So on Desmos, we're going to go to functions. And we're still doing normal distributions. So I'm going to click on that first. I'm going to click on that first. We want the mean to be 0 and the standard deviation to be 1. Because if we go back and look, what is the mean? The mean is 0 and the standard deviation is 1 if we're trying to find the z-score. So I'm not going to actually type anything inside this parentheses. Now, in order to go backwards, we're going to hit the decimal or period, and we're going to use another function. We're going to use another function. So we're going to go back to functions. Right? We're going to go back to distributions. And we're going to click on the one that says inverse CDF. So what's like the inverse of adding 5? Subtracting 5. What's the inverse of giving you the percentage? Well, giving me the z-score. So I'm going to click on the inverse CDF, but you have to make sure you put the period in between these two things. So far, so good. And now if I type the percentage that I want to the left of the z-score as a decimal, 25% will not work, but 2.5 or 0.25 will work. So actually I put my z-score in the wrong place. I put it between -1 and -2, and it should have been a little bit closer. It should have been over around -0.67. So if we go back over here, my z-score should have actually been like right here. So what z-score represents the lower 25%? That would be a z-score of -0.67. And if you want to check on the table, we can actually look up -0.67, go down the left side, across. -0.67 on this table that we used the other day is 25.14%. That's the closest thing on this table to 25%. Now, why is it not exactly 25%? Because we rounded the 0.67. Desmos didn't round it. Desmos gave me a whole bunch more decimals. So if I could look all of those up on a table, we could find 25% exactly. So Desmos does it for us. Number 2, or the next part. Find the z-score that represents the 90th percentile. What do we mean by percentiles? Percentiles. What do we mean by percentiles? The 90th percentile. If you're to the 90th percentile for height, what does that mean? That means you're taller than 90% of the people in that group, whether it be your gender, your age, whatever the case may be. if you've scored in the 90th percentile on an EOC, end of course test, what does that mean? That means that your score was better than 90% of people that took that exact same test. That's what 90th percentile means. So we're looking over here somewhere. What's the Z-score over here? And 90% would be all of this over here. All this shaded region would be equivalent to 90%. So if we go back to Desmos, what's the only thing that we need to change in Desmos? We need to change the 0.25 to 90. So we're going to change the 0.25 to 0.90. Yeah, it's not going to work if you do that. Just 0.9 would give you the same answer, yes. Just 0.9 would give us the same answer. So we see that we get a Z-score of 1.28. So this Z-score of 1.28 would be representative. So period first. Click on functions, go back to distributions. Where you found the first thing, and you're going to do the one that says inverse. So that was right there. All right, so now we get a Z-score of 1.28, will give me about 90%. If we look 1.28 up on this chart, 1.28 is 89.97%. That's the closest thing to 90% on your chart. So Z equals 1.28. So this Z-score right here, 1.28. So far, so good. Number 3, find two Z-scores that represent the middle 30%. And this one's a little bit different. I can't just go put 30% in the parentheses. I wish it was that easy. So what are we looking at? We're looking at the middle 30%. So this middle piece, this in the middle, is going to be 30%. And we're looking for the Z-score here and the Z-score here. But what I put inside the parentheses, the percentage I put inside the parentheses has to be the percent to the left of the Z-score that we're looking for. So if I'm looking for this first Z-score, what is this percentage to the left? It's not 30% because 30% is in the middle. How can we figure this out? What does all the percentages have to add up to? 100. We take the 30 away from the middle, we get how much? 100 minus 30? 100 minus 30 is 70. But what does that 70 have to be divided to? That 70 has to be divided evenly into those two areas on either side of the 30%. So we're going to take these two numbers and divide by, we're going to divide that by 2. 70 divided by 2 is, so there's 35% on this side, and there's 35% on that side. So when I go back to Desmos to find the Z-score, to find the one on the left, we're going to change the 0.9 to 0.35. We're going to change the 0.9 to 0.35 because there's 35% on the left side of that Z-score. And before we even do the other one, what do we think the other one might be? The same, but not negative, positive. So let's check. That is true, so negative 0.39. So negative 0.39. So this is Z1. So call it Z1 is going to be negative 0.39. Z2 will be 0.39. But in order to check that, what do we need to type in Desmos? Not 35%, not 30%, but we need to add up the 35% and the 30%. Because that's everything to the left of our second Z-score. And 30 plus 35 is 65. So we're going to change the 35 to 65. And you notice we do get the exact same number, but positive. Because the bell curve is symmetric, and it should be the same. All right, so that's if we wanted to find the Z-score. What if we wanted to be a little bit more specific and say, hey, we have an SAT math score here, and I got to make a certain score on this SAT math score to be considered for maybe a scholarship, or maybe to try to get into Georgia Tech's STEM program, or whatever the case may be. So the average is 520, the standard deviation is 60. So if we were to draw the bell curve, and by all means, you don't have to draw the bell curve every single time, But 520 would go in the middle now. We have 580. We have plus 60 more would be 640 and 700. And going the other way, 520 minus 60 would be 460 and 400 and 340. And we want to know what score would represent the lower third. So what percentage would the lower third be? 1/3 is what percent? 33.3%. So we're looking for whatever this is has to equal 33.3%. Whatever's to the left would be 33.3%. So in Desmos, I'm not going to leave this blank anymore. We know the average and we know the standard deviation. We know the average is 520 and we know the standard deviation is 60. So now notice I don't get a number that's like negative 0.67, 1.35, 2.06. I don't get a number like between 0 and 3 and negative 3. I get a number like 543. And that's a number that's an SAT score. So now it's actually changed it to SAT score. I just hit the wrong button. So let's hit Control Z right quick. And now let's see what percentage we want inside the parentheses. We currently have 65%. We want 33.3%. And 33.3%, the threes just really keep going. So we can type as many threes as we want. So what score is going to give me a score that would be better than 33.3% of the people that took the SAT? 494. A 494 would be better than 1/3 of the people that took the SAT. 494. You had a question?
Yeah, I can ask about this.
All right, I'll help you with that in just a second. So 494 would be that score that we were looking for. What about part B? Find the score that represents the 80th percentile. Well, what does percentile mean? Percentile just means we did better than 80%. So 80% is on the left. That's pretty good. That's basically the same thing we just did. So do I need to change anything in here? Just the 0.3333. We can change it to 0.8. We can do 0.80 if we want. It's just going to give you the same answer. So we see a score of 570. We see a score of 570 would put me in the 80th percentile. Maybe in order to apply for the scholarship, I have to be in the 80th percentile, which means I have to make at least a 570 on the math portion of the SAT. Part C, we're looking for two scores that separate the middle 50%. I can't just type 50% in. I wish I could. So we want the middle to be 50%. So if the middle is 50%, how much is over here? 25. So for the first score, let's call it S1. What are we going to type in Desmos? 25% as a decimal would be 0.25. So go back to Desmos. The only thing we need to change is the 0.8 to 0.25. We get a 480. So a 480 would get me this first score. So a 480 to the second score. What would we type in for the second score? We would have to add the 25 and the 50 together, which I think is what I heard. So we would change the 0.25 to 0.75. So a 560. So a score between 480 and 560 would represent the middle 50% of everyone that took the math portion of the SAT. So if you were somewhere between 480 and 560, you would be considered the middle 50%. And number 5. Number 5 is kind of review. We did number 5 a couple days ago, something very similar. But now we can use this in Desmos to actually answer number 5 today as well. So we got an SAT, ACT. Somebody took both tests, and we want to know which one they did better on. So could we just find the Z-score? Yes. And the one that has the highest Z-score, the furthest to the right, is going to have the highest percentile rank. But why can't we just find the percentile rank in Desmos? And we can. So that's what we're going to do. We're actually going to find the percentile rank. So if I'm looking for the percentage in Desmos, They didn't give me the percent. I'm looking for it. You will delete the inverse part. We do not need the part that says inverse, because I don't know what the percent is. I'm trying to find the percentage, and I'm going to hit that check mark. So it said the average SAT score was 1050. So 1050, and the standard deviation was 90. And we want to know this guy made a 1200. So that's going to be the max. Like we're going to put 1200 on the right. We want to know what percent did he do better than. So 1200 is going to be the max. So he's in the 95th percentile. So he did better than 95% of people that took this SAT. Can we do the same thing for the ACT? I'm going to actually click down here because I don't want that one to go away because I might forget what it said. So I'm just going to click down here and do it a second time for the ACT. We're going to go down. We're going to find our normal distribution again. So if you weren't here yesterday, this is exactly what we did yesterday. Normal distribution. The ACT, the average was a 22, and the standard deviation was a 3. So 22, 3. We were going to find the cumulative probability. And what did he make? He made a 26. So the max is going to be a 26. So on the ACT, he only did better than about 91% of people. So he only did better than about 91% of people. But on the SAT, he did better than 95% of the people. So which one did he do better on? The SAT. So SAT, he was in the 95th percentile. The ACT, he was in the 91st, if we round, percentile. Which one did he do better on? The SAT. And you might write a sentence. He did better on the SAT because the 95th percentile is better than the 91st percentile. Or he did better on the SAT because he had a higher percentile rank, period. And we're done with our notes today.